Hi Lincoln! In this video, we're going to go over homework solutions for Monday, June 23rd. Let's get straight into number 7. So this question is asking us to use the product of two positive consecutive even integers, and that is 168. And we need to use that information to form a quadratic equation and solve it to find the two integers. So first of all, we need to think about how to express the two positive consecutive even integers. How do we even do that? And how do we use that to express that the product of it is 168? Let's think about it. So first of all, let's think about what consecutive is. Consecutive numbers are like 1 and 2. How? Because one comes after the other naturally, right? Same with 1, 2, 3. They're all consecutive numbers because it comes one after the other without any skipping any numbers, right? So it means that these two numbers have to come after each other, but what are we looking at? We're looking at positive numbers. So it needs to be greater than 0. It's got to be greater than 0. And last condition is they're even numbers. So it's got to be like 2, 4, 6, 8, 10, blah, 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 right? So it's got to be positive and it's got to be consecutive. So it's going to be something like 2 and 4 or 4 and 6, right? You get the idea now. So how do we express it in algebra? That's the key. So in algebra, a very, very common expression to express even numbers is the expression of 2x. Why? How does that work? Well, if you think about it, anytime we multiply the number 2, it's going to be equal to an even number, right? Yeah. So coming back to this problem, if we set the first integer as 2x, what is the second integer going to look like? Yeah, it's going to look like 2x plus 2. You get it? Because if we do 2x plus 1, what is that? First of all, it's going to be an odd number, right? So it doesn't fulfill the conditions that we're looking at here. So it's going to look like these two. So we're going to use these expressions to form a quadratic equation. How do we form a quadratic equation? We're going to use the information that we're talking about a product, and that product is 168. So let's form it. So 2x times 2x plus 2 is going to equal to 168. So that is our quadratic equation here. So I'm going to solve it. 4x squared plus 4x minus 168 is equal to 0. So you notice that every number here is divisible by 4. So if we do that, we are going to get x squared plus x minus 42 is equal to 0. So if we factorize that, we're going to get the factors 6 and 7 and minus and plus. So it's going to look like x minus 6 times x plus 7 is equal to 0. So if we go over here, the two values of x in this quadratic equation are either going to be 6 or minus 7. But we need to figure out which one of these are the number we're looking for. So what was one of the conditions? It said that it's got to be even, it's got to be positive and consecutive. So remember, the x we're looking at is part of the first one, okay? First integer. We're getting one of the numbers. So it needs to be positive. That automatically cancels out minus 7. So we're starting with 6. Since we started with the two integers 2x and 2x plus 2, we're going to straight away substitute x for 6. How does that look like? It's going to give us the two numbers of 2 times 6, which is 12, and 2 times 6 plus 2, which is 14. So our answers are 12 and 14. Okay, so let's move on to the next question, number 8. Two men, A and B, are working together to complete a task in 4 days. Okay, so that's like the first piece of information here. If B completes the task on his own, he takes 6 more days than if A did the task on his own. Use the information to form an equation. Solve the equation to find the time that A takes to complete the task on his own. Okay, so we know how much it takes for A and B to work together and finish a certain task. But we don't really know anything else. How are we supposed to solve this? So if I were to set X as the number of days that A takes to complete the task, X plus 6 is going to be the number of days that B takes to complete the task. Because how do I know that? It is given by this sentence right here that B is going to take 6 more days to complete the task than when A does it alone. But why am I setting X as the number of days that A takes? Because that's what we're trying to get here. It says we need to find the time, which is in days, that A takes to complete the task on his own. That's why we're setting X as the days that A is going to take to complete the task. So from here, how do we get the answer? We need to use something called a work rate. So problems like these where we don't have an exact measurement to, calculate A and B, if it's very unclear like this, how do we set the variables A and B, etc., we need to use something called rate. How do we do that? Work rate is the reciprocal of the time taken. What does that mean? So basically, A's rate is going to look like 1 over X. And B's rate is going to look like 1 over X plus 6. Okay? And working together, the combined rate is 1 over 4, right? How do I know that's 1 over 4? We can look at the first sentence right here, that working together can complete a task in 4 days. What does that mean? What is their rate? What is their daily rate? How much can they work in a day together? They can finish 1/4 of the job in 1 day. Yes? Yeah. So that's where we're starting here. So how do we form the equation now? Since we know that if we add the work rate of A, which is 1 over X, plus the work rate of B, which is 1 over X plus 6, that's going to be equal to 1 over 4, right? It's only talking about the daily rate. You understand? So from here, what we can do is we can eliminate the denominators by multiplying through by 4x times x plus 6. So what we're going to do is just do that. So it's going to look like 4x plus 6. Okay, let me just kind of write it out for you. So 4. Okay, let me, oh my god. Yeah, let me just space it out. That's going to make it look easy. Yeah, let's start here. And then we're going to multiply 4x, x plus 6. We're going to combine all of the denominators here. Yeah. I know it kind of looks weird, but I don't really have space. So that's going to look like 4x plus 6 plus 4x is equal to x times x plus 6. So we're just getting rid of the denominators here. And then we're going to expand those. 4x plus 24 plus 4x is equal to x squared plus 6x. So we're going to move over here. And if I rearrange them, it's going to look like minus 8x minus 24 is equal to 0. So x squared minus 2x minus 24 is equal to 0. And the factors are going to be 6 and 4. So our factorized equation is going to look like x minus 6 times x plus 4 is going to be equal to 0. And our two values of x are 6 and minus 4. But what is the x again? The x is a number of days. Is that positive or negative? Obviously, that's going to automatically cancel out the minus 4y because x can only be greater than 0. So we need to write that condition in the end so that we are showing the examiners that we actually know why it is not the negative, okay? So, all right, we got the x value. Is that the end? Let's check. So it says find the time that A takes to complete the task on his own. So, yes, we are done. The answer is going to be 6 days. So make sure you know the units. And so let's move on to number 10. It says if 5 is a root of equation this, find the value of c and the second root of equation. So there's two tasks that we're required to do here. First of all, get the value of c. And number 2, what's the second root of the equation? So let's solve the first part first. But in order to solve this, we need to understand, okay, what does it have to do with 5 being a root, blah, blah, blah? Okay, we need to understand that first. So let's talk about roots. Remember, what is a root? Root is a solution. And solutions are equal to intersections, right? So we learned this in class. So from here, we can actually derive something. What if I have a example equation of x minus 3 times x plus 2 is equal to 0. What are the roots here? Roots here are going to be x is equal to 3 and minus 2, correct? Yeah, but on the other hand, I found the roots, but I want to put them back in. I want to check how it looks like. So let's start with x is equal to 3. If I put x as 3, for example, what is it gonna look like? It's gonna look like 3 minus 3 times 3 plus 2 is equal to 0, and up until here, yeah? How does that look like? So 3 minus 3 is essentially 0 times 5. What does that look like? That is gonna be equal to 0. So what is it telling us? Originally, we had the equation set up to be equal to 0, yes? And then, so when we put in the roots back into the original equation, what do we get? We get it equal to 0. This happens for any root out there. Any root to an equation, if we put the root into the equation, we get equals to 0. So we're going to use that information here. So it says 5 is a root of this equation. So what do we do? So let's put x as 5. If I put x as 5, what is it going to look like? 2x squared minus 3x plus 6c is going to equal to 0. Yeah, because how? We just proved why if we put root in it, it's going to equal to 0. So basically, continuing from here, let's actually put it in. So 2 times 5 squared minus 3, 5 plus c is going to be equal to 0. So this is going to let us know what the value of c is, right? So yeah, So 25 times 2 is going to be equal to 50 minus 15 plus c is going to be equal to 0. So c is equal to what? Okay, 30 minus 35, right? Yeah, so we know the value of c. That is the first part. Yes? Yep. So now let's go to the second part. So for the second part, what is the question? It's a second root of the equation. So since we know the constant c, let's actually rewrite the equation so that it's clearer for us. Okay. So it's going to look like 2x squared minus 3x minus 35 is equal to 0. So from here, that is the original equation. We need to get the second root of the equation. How do we do that? We can factorize this quadratic equation to get the two different roots, and we can cancel out the 5 because we already know that, and we can find out the second root. So let's do that. 1 and 2, and the factors will be 5 and 7. So minus and plus, that's going to give us x minus 5 times 2x plus 7 is going to be equal to 0. So what are the two values of x? X is equal to 5 and minus 7 over 2. So yeah, as I said, we can automatically cancel out 5 because we already know that, and therefore the second root is going to be x is equal to minus 7 over 2. Yeah. So yeah, I noticed that you got both of the correct answers correct. Yeah, I think you were just kind of confused about the way it is solved, and I think you were just wondering about it. And I hope that this explanation clears it up. Okay, let's move on. So number 4 here. A recycling firm collects aluminum cans from a number of sites. It crushes them and then sells the aluminum back to the manufacturer. The profit from processing T tons of cans each week is P dollars, where the relationship between P and T is in this equation right here. P is equal to 100 tons minus half ton squared minus 200. So always remember, functions are what? They're relationships. Yes. So their relationship between two variables. So what is the two variables here? Instead of x and y, it's going to be t and p. Yeah. So we need to first identify what's going on like this. And so next up, we see that it's telling us to complete the square. That's the mathematical method that is looking for us to do. And what's the job that we need to get done here? Find the greatest profit the firm can make each week and how many tons of cans it has to collect and crush each week to achieve this profit. So it's looking for two pieces of information. The first piece of information is the greatest profit. How do we know what's the greatest profit here? It says the profit is P dollars. So what? Greatest profits. Literally maximum P value. Yes. And what is it? What is the other information it's looking for? The how many tons. How is the tons represented? It's one of the variables in the function, right? So T tons. So the corresponding T value. So when we find the maximum P value, we're finding the corresponding T value also. So how do we solve this? So just don't think of it as too complex of a question. Let's look at it one by one. So let's start by completing the square because that's what it's telling us to do. So we have the function P is equal to, I'm just going to rearrange it so that it just looks like what we're used to. 1 over 2 t squared plus 100t minus 200. Okay, from here, what are we going to do? We're going to get we're going to take out the minus 1/2. And it's going to look like this. Yeah. From here, we're gonna complete the square, so it's gonna look like 200t plus 200 over 2 squared minus 200 over 2 squared minus 200, yeah? So since we can complete the square by using until here, we need to take this constant out of the parentheses. How do we do that? We need to multiply this number, so we're going to do that straight away. We're going to get 1 over 2 parentheses t minus 100 squared. And then we have a minus and a minus, so that's going to be plus. That's 100. So it's going to be 1 over 2 times 100 squared. So 100. So 10k minus 200. So what is it going to look like? It's going to look like 1 over 2 minus 1 over 2 t minus 100 squared plus 5,000 minus 200. So 4,800. Yeah? So that is how it looks like when we complete the square. So what do we do now? What is the greatest profit? So in order to understand this, we can quickly sketch this function. So whenever you don't have like a function that has like, our regular x and y's, that is okay. We can still represent it on an xy plane. In this case, it wouldn't be the xy plane, it would be the pt plane, right? So notice how it looks like. Look at the relationship here. We see when the t value changes, the p value is correspondingly, changing. So what does that look like? We are going to put here as t and here as p. Because why? Every time t changes to a certain value, the p value changes correspondingly. That is why. So we notice that when the t value is 100, we know that the p value is going to be 4,800, right? So we notice also that since the coefficient of t squared is a negative number, how is the quadratic function going to look like? It's going to look like an N shape, right? Yeah, but how do we know where it's going to pass the y-axis? We look at this value. Because why? This is the y-intercept, remember? Notice how this is looking like ax squared plus bx plus c. We said that in this case, the c value is going to be the y-intercept. Yes? Exactly. So coming back from here, we know that it's going to cross at minus 200. So our brief sketch is going to look like that. Our vertex here is going to be the what? The maximum p-value. Yes? Exactly. So since we have the maximum p-value, what is also asking us to do is finding the corresponding t-value. What is the corresponding t-value? 100. Because why? At t is equal to 100, p-value is 4,800. What does that mean? P-value is at its maximum, which is 4,800 at 100 tons of cans, right? So now we have both of the information we need. You're just going to write it out. So basically, P is 4,800 and T is 100. And then that is basically our answer, actually. Yeah, moving on to number 5. By writing the left-hand side in the form A times x plus p squared plus q, show that the equation has no real roots. So this was actually given before you learned the discriminant. So this was actually to serve as a preview for discriminants. Yeah, so we learned this actually today in class. So let's kind of go over what it means. So the discriminant is essentially a part of the quadratic formula that allows us to determine how many roots there are in a quadratic equation, right? So the formula was D is equal to, D stands for discriminants. So D is equal to B squared minus 4AC when we're talking about Y is equal to AX squared plus BX plus C. So the B and the A and the C comes from this function. Yeah, so coming back to our quick question here, whenever it has no real roots, remember, D is going to be equal to what? Less than 0. Yes, remember? So it's not going to touch the x-axis. Whether it be that, it's not going to touch the real x-axis because why? It has no real roots. It only has 2 imaginary roots, remember? Yeah. So coming back to our question here, we need to first organize it in the vertex form. So we call this the vertex form, remember? So yeah, let's do that first. So we have minus 2x squared plus 8x minus 13 is equal to 0. So we're going to organize it in the vertex form. So we take out the minus 2 and keep the x squared in the parentheses. And from here, we add the 4 and the minus 4. And we close the parentheses. Minus 13 is equal to 0. And we keep going. So minus 2 squared. And as we take out the minus 4, we are going to multiply by minus 2 at the front. So that's going to look like plus 8 minus 13 is equal to 0. So it's going to look like minus 2 times, x minus 2 squared minus 5 is gonna be equal to 0. So from here on, how do we show that this equation has no real roots? Okay, so this is actually a way to solve this question without using the fact about discriminants. Let's look at how. So you know that discriminants just allow us to straight away find out there's no real roots when it's in this form, which is ax squared plus bx plus c is equal to 0, right? That's when we use the discriminant. But here, it says that first of all, we're organizing in the vertex form, which is not when we use the discriminant. So how do we actually solve this then? Let's look at it. So from here, if I were to kind of get the answers, how do I do that? So I would organize it in the form of x minus 2 squared times minus 2 is going to be equal to 5. And I'm going to organize all of the numbers to the right-hand side, leaving only the x in the left-hand side, right? So it's going to look like this. Okay, and let's move on to over here. So if I apply the root to the both sides, so from here, if I apply the root to the both sides, how does that look like? That looks like x minus 2 is equal to plus minus root minus 5 over 2. This is the catch. What happens? Look at this right here. Can that exist in real numbers? No, right? Since root 5 over 2 is not a real number, and what is x if you rearrange it? X is actually equal to 2 plus minus root minus 5 over 2, right? Has no real roots. So without using the discriminants, we can kind of explain it using logic. So it's, as it says show, right? You kind of have to explain it in these types of questions. It's called like a mathematical proof. So let's move on to number 7 over here. This one, you were incorrect when you did solve it. So I'm gonna go over how it looks like. So it says letter A, it says write x squared minus 10x plus 35 in the form of the vertex form. Yeah. And letter B is hence or otherwise find the maximum value of this function. So notice how this function isn't what we actually look at regularly, because why? Look at it. It's a rational function, yeah. It's a rational function, but look at it. It's triple. So we don't really talk about it usually, but it's actually pretty easy. So let's start with letter A. So it says write the equation in the form of a vertex form. So let's start with that. X squared minus 10x plus 35. Since we already practiced this, I'm just going to speed through, okay? So yeah, here we have the vertex form. That's the answer for letter A. And what's for letter B? So hence or otherwise find the maximum value of that. So we notice that inside the parentheses, we're looking at the same equation that we saw in letter A. So what can we do here? We can organize that parentheses in the inside as the vertex form, because it says hence. That means we can use the information we got from letter A and B, right? So yeah, since instead of writing x squared minus 10x plus 35 to the power of 3, we're going to actually use the information we got. We're going to say x minus 5 squared plus 10 to the power of 3. Yeah. So how do we find the maximum value if we didn't study functions to the power of 3? How do we do that? It's actually pretty simple. We're not going to solve it in like an algebraic way. We're going to use logic. So think about it. If this fraction is going to be the biggest number ever, think about it. What can we determine about the denominator? It's going to have to be the smallest denominator equals big fraction value. Okay, if you don't understand this, I'll give you a quick explanation. So imagine we have 1 over 2 and 1 over 3. Can you tell me which one is bigger? So if you think about it, 1 over 2 is bigger than 1 over 3. Think about it as a pie. So 1 over 2 is this much, right? And 1 over 3 is going to be this much, yeah? So 1 over 2 is going to be greater than 1 over 3. That applies to any fraction. So when the numerator is the same, the denominator, the smaller the denominator is, the whole fraction becomes bigger. So this applies here also. That means we're going to have to get what? The minimum value of x minus 5 squared plus 10, right? Yeah. So that is the essential question that is asking here. It's masked. So it's masked, but it's actually pretty easy if you uncover it. So let's see. Minimum value. So if we quickly draw and sketch that quadratic equation, it's going to look like something like this. Yeah? So the line of symmetry is going to be x is equal to 5. We know that. And our minimum value right here is going to be 10. Exactly, because we have the vertex form. So what is that? What is the minimum value? It's going to be 10. So we know that the minimum value of this whole thing is going to be 10. So now we need to get the minimum value of the whole fraction. So we're going to plug it in. So finally, thus, the minimum value is going to be 1 over, okay, so 10, Okay, 10 to the power of 3. So that's going to be 1 over 1,000. That's going to be your answer. Okay, so let's move on to number 8. So this is a pretty tricky one. You need to kind of combine all of the information you know about geometry and stuff. But after you kind of get to grasp, it's not going to be that hard. But let's see. So just look at the problem right here. Just look at it. It looks super weird. But we can get through it, don't worry. So it says they're traveling in 2 straight roads that are perpendicular to each other. So what does that tell us about the angle here? It's a right angle. So we start from there. And then they meet at point O. We already see that as shown in the diagram. So first piece of information it gives us is the first car starts 50 kilometers west of O and travels east at the constant speed of 20 kilometers per hour. And the second piece of information is that at the same time, the second car starts 30 kilometers south of O and travels north at the constant speed of 15 kilometers per hour. So what do we know? Think about it. So from O, we know the distance where it starts. So if we call this a starting point for each car, so this is the first car and this is the second car, and we know that the starting point distance for the first car is going to be 50 kilometers. And for the second car, it's going to be 30 kilometers. Yeah? How do we know that it's the first second? Because north, east, west, and south. And we know that the first car starts west. So it's starting from here. And the second car starts south. So it's starting from here. So that's how we know it's going to be first and second car. So from here, we know the distance. And we also know the speed. So the first car is traveling at 20 kilometers per hour east. And the second car is traveling at 15 kilometers per hour north. So what do we do with this information? Think about it. Well, if we just stop here reading the question, we might actually not get how to solve it. But if we look at letter A, it kind of gives you a hint. Look at the way this equation is structured. Is anything familiar? Did you wonder, why is the D squared? Why is a D squared? Think about it like a puzzle. When do you use this? When do you use these types of things? Well, the answer is we need to use the Pythagorean theorem. I'll tell you why. So the time we use D squared, or basically the distance between the two cars, right? That's D. Okay, what does it resemble? It's giving triangle. So it's giving triangle, and we know that this is a right triangle, right? Because it's perpendicular. So what do we do with this D? We're timesing it by 2 so that we are getting the square of the hypotenuse of the right triangle, yes. So that's how we know we're going to use the Pythagorean theorem. Oops. So let's do that. So let me just redraw the triangle here because just easier to see. So I have this right angle. I have 30 kilometers, 50 kilometers. I don't know the hypotenuse. That's going to be D. So, but think about it. They're moving cars. So are these lengths 50 kilometers and 30 kilometers going to be stagnant? Is it always 50 kilometers, always 30 kilometers? No, think about it. Because this car from this point is going to travel this way. So the distance between this point and this point is going to get shorter and shorter and shorter, right? Because why? The car is moving that way. Exactly. So same with this. If the car's starting from here, that's 30 kilometers. But if the car's moving this way, the distance between this point and this point is going to get shorter, shorter, and shorter. Exactly. So we need to also think about the speed. So how we set up the equation here is going to look like this. So let's say I'm calling this length 1, and I'm calling this as length 2. So let me think about length 1 first. How do I get the distance of length 1 at any point of time? So that's going to look like 50 minus 20 t, considering that t is the hours. So every hour, at any given hour, the length of L1 is going to be 50 kilometers minus 20 t. And that's the units in kilometers. And similarly, the length of L2 is going to be 30 kilometers minus 15 t. And the unit's going to be kilometers. So we have the length of L1 and L2 here. That was the first step. The second step is showing that the distance between these two cars, it's this equation. How do we know? Well, from here, I know that since d squared is equal to what? L1 squared plus L2 squared? Yeah. So I'm just going to plug in what I have here. So if I say d squared is equal to 50 minus 20t squared plus 30 minus 15t squared, if I do the math here, I'm going to get 400t squared minus 2000t, 2000t plus 2500 plus 225t squared minus 900t plus 900. So from here, if I rearrange the numbers and add them together with like terms and stuff, so I get 625t squared minus 2900t plus 3400. Exactly. So is this equal to what we were supposed to prove? We did it. So what do? We showed it? Shown. Okay, so we did the first part. That was A. Now let's do B. It says, hence, find the closest distance between two cars. What does it mean? Closest distance. That means minimum D value. Because what? D is the distance between two cars. So, how do we get the distance that is minimum value? The only thing we know is the equation of d squared. How do we get d value? Well, just think about it. If we want to get the minimum d value and we only know this equation, that means we automatically need to get the minimum d squared value, right? That means minimum d value. So, what does that mean? When 625t squared minus 2900t plus 3400 is smallest. Exactly. So what does that require us to do? It's gonna lead us to get the vertex form of the quadratic equation and get the minimum point. Exactly. So we're gonna do that right now. So if I were to just organize it, it's going to look like d squared is equal to 625 parentheses t squared minus 2900 over 625t parentheses plus 3400. And if I do the math, it's going to look like 625 parentheses t squared minus 116 over 25t plus 58 over 25 squared. And if I take the minus 58 over 25 squared out of the parentheses, it's going to multiply by 625. So it's going to look like 3,364 over 625 times 625 plus 3,400. So notice how the 625 will cancel out. So we only do minus 3,364 plus 3,400. So what does that look like? that looks like d squared is equal to 625 parentheses t minus 58 over 25 squared plus 36. So if I quickly sketch this quadratic equation or quadratic function, it's gonna look like a U shape because the 625 is a positive number, so it's gonna be a U shape, and we automatically know that the vertex is gonna be the minimum. So what is a vertex? We get 58 over 25 comma 36, and therefore our 36 is gonna be the answer to our question for minimum value of d squared. So beware, we're not stopping here, because why? We're gonna get the minimum d value. We're not getting d squared value minimum. So from here, thus, if we have d squared is equal to 36 as the minimum value, how do we get d? We just apply the root on both sides. So it's gonna look like d is gonna be equal to plus minus root 36, which is plus minus 6. And how do we know if it's plus or minus? Because why? Distance is always greater than 0, right? So we're gonna say d is equal to 6 because d is always greater than 0. So that is gonna be your answer. So it's gonna be 6 kilometers. Yeah, that was a tricky one, right? Yeah, let's go. So next we have number 5 over here. So it says the height of an object in meters above ground is given by h is equal to minus 16t squared plus 64t plus 990, and t is greater or equal to 0, where t is the time in seconds. We're gonna find the time it takes for the object to fall on the ground. Give your answer to 3 significant figures. So this is what you would use the calculator for, right? Because you're gonna get an answer in 3 significant figures. So, okay, we need to first understand what this is saying. It says we need to calculate the time of when the object falls to the ground. And we only know an equation about the height. What can we use? What type of information do we have to get in order to, calculate when the object is gonna fall on the ground? Think about it. When the object is on the ground, what is the height? What is the height of the object above the ground? It's gonna be 0 meters, right? Because it's in meters. It's 0 meters. Think about it. So what? The h is gonna be 0. And what do we know about the h? We have a whole equation about that. So we're gonna say minus 16t squared plus 64t plus 190 is equal to what? 0. Exactly. So we're gonna get the t, which is the time here. We need to get the time for the object to fall on the ground, and we need to get our answer to 3 significant figures. So when it says 3 significant figures, we're probably gonna get a whole long decimals, which is indicating that we should use the calculator. So what we're gonna do is we're gonna quickly simplify this equation right here, because it looks like they're all even numbers. We can divide them by 2, and then we can plug them into the calculator, or you can just use the polynomial simulator, which is the polynomial root finder in your calculator. Then you can get it straight away as well. So let me just simplify it because, for convenience. Let's see. Okay. So from here, I'm gonna have to put it into calculator, guys. So continuing, if I put it into the calculator, one of the t values are gonna be 5.98 in 3 significant figures, and the other value is going to be minus 1.98. So those are going to be my two t values. However, and 3 significant figures. However, we are only getting the time in greater than 0. Why? Because can you measure time in minus? No, you can't. So the only way you can get the time is that's greater than 0. So our answer is going to be t is equal to 5.98, 3 significant figures, and because t is greater than 0. So we always need to write the condition y. There you go. That is our answer for number 5. And let's move on to number 5 over here. So this is actually one of my favorite types of questions because I don't know. I think just exponential functions, questions like these are just fun. Okay, so this one we need to understand how to express different numbers so that it ends up in a quadratic equation. Basically, it's what it is. Because also you can get the hint because the unit's name is quadratic, so it's always going to be something related to quadratics, right? So yeah. So if I were to express 9 times 1 plus 9x minus 1, parentheses, is equal to 10 times 3x. Oh, this is all different numbers. How do we know? Well, 9. Notice how 9 is going to be equal to 3 to the power of 2, right? We're going to use that because we have this random number that is the base of 3, but we don't have any other 3's in here. How do we know that? So in order to get the x value, we need to somehow kind of make it dissimilar. And in order to solve any exponential function, we need to make the bases equal, right? Make the bases equal. So that is our first primary goal right here. So that's what we're going to do. So instead of 9, we're going to say 3 over 2 times 1 plus 3 over 2 to the power of x minus 1 is equal to 10 times 3 to the power of x. Yeah. Okay. Stop here for a sec. Okay, from now, what do I do? So, this is a trick. Look at this one. You can expand this. I'll tell you how. Oh, this is wrong. There you go. So, we can expand this. I'll tell you how. So, first of all, just consider this as, a random number. We're going to distribute. Let's see how it looks like. It looks like 3 squared plus 3 squared times 3 squared to the power of x minus 1. Yeah? Okay. And what is 3 squared to the power of x minus 1? That is 3 squared, to the power of 2x minus 2, right? Because even for the exponents, it was just 2 times 2x minus 1, so we're just going to distribute it and we get 2x minus 2. And from there on, we are going to use the exponent rules, so indices rules. So when we're multiplying together and we have the same base, what can we do? We can add them up, right? That's the indices rule. So basically, what can we do? We can do 3 to the power of 2 plus 2x minus 2, right? So what does that equal to? 2 cancels out. 3 to the power of 2x. That's what we get. So instead of all the different numbers, we actually end up with 3 to the power of 2. Okay, let me write that in different color. 3 to the power of 2 plus 3 to the power of 2x is equal to 10 times 3 to the power of x. Yeah, so this looks pretty workable, right? So moving over here. Okay, now we want to notice this one. 3 to the power of 2x. How can we express it in the other way? 3 to the power of 2 and then x. Or we can do 3x to the power of 2. Okay, let's do that one. plus 3 to the power of 2 minus, if we, move over to the left-hand side, that's going to look like 10 to the power of 3x. Ooh, do we see it now? Do we see it now? What do we notice? We have 3 to the power of x as a common term in two different terms, right? Exactly. So, these expressions are common in two terms. So if I put 3 to the power of x as a, for example, just a random variable, I'm going to get a squared plus 3 to the power of 2 minus 10a is going to be 0. So what is this? A quadratic expression. So if I rewrite that, it's going to look like this. So what do? I'm going to solve it like I always do. I get the factors and I get the values of a. They're going to be a is equal to either 1 or 9. Yeah, so we don't stop here though, right? Because we set the a value as 3 to the power of x, we're going to switch it back. 3 to the power of x is going to be either 1 or 3 to the power of x is going to be 9. So just think about it. What exponent do you need to have to the base of 3 in order to get 1? It's going to be 0. Or what is the exponent to 3 when it's equal to 9? 2. So x is either going to be 0 or 2. That is your answer here. Next, we have number 7. It says solve the equation 4 to the power of x plus 0.5 minus 17 times x 2 to the power of x plus 8 is equal to 0. Okay, this is super complicated, right? But we can do the same way. We need to somehow organize it so the base, somehow two or more terms have the same expression of 2 to the power of x. Because why? This is an exponential equation, and we need that in order to change it into a quadratic equation. So what do? I see 4 to the power of x plus 0.5, and I have minus 17 times 2x plus 8 is equal to 0. Let's see. So can I change 4x something into a base of 2? Yeah, probably. So let's try. So if I do 4 is equal to 2 to the power of 2, and I keep everything else, okay, so I want to expand this. Can I do that? Yes. I can expand this 2 and multiply to other ones because they're just like, normal algebra. You can distribute the numbers within the exponents. So it's going to look like this. 2 to the power of 2x plus 1, right? Because 0.5 times 2 is equal to 1. So, and then we have, okay, but before we go ahead, I just want to keep talking about this one. What do we know about this? So we remember that when we have a to the power of m plus n, that is actually equal to am times an, right? We actually looked at the opposite, switched these up, and we got the opposite rule in the question above. Remember? We used this in this law. We're going to use it the opposite way. So you notice how it's am plus n type of structure right here. So we can separate them into 2 to the power of 2x times 2 to the power of 1. Exactly. So that's how we're going to write it down. So from here, we can say it's actually equal to 2 times 2 to the power of 2x minus 17 times 2x plus 8 is equal to 0. So you notice again, we can do, if 2 to the power of x is equal to a, we can switch it up. You can say 2 times a squared minus 17a plus 8 is 0. So if we factorize it, yeah. So it's going to be a minus 8 times 2a minus 1 is going to be equal to 0. So our two values of a are going to be 8 and 1 over 2. So we don't stop here, right? Because we need to substitute a to the original equation. That's going to be 2 to the power of x is going to be 8, or to the power of x is going to be 1 over half. So remember, 2 to the power of 3 is going to be equal to 8. And 2 to the power of minus 1 is going to be the reciprocal. So it's going to be 1 over 2, right? Remember that. So our answers for this question are going to be x is equal to 3 or x is equal to minus 1. Yeah, so we kind of combine all of the things that we learned in class in this one problem. I think it's super fun. Next, we have sketch the following graphs labeling all axis intercepts. So, okay. So sketching the following graphs labeling all axis intercepts, we're talking about the x-intercept, the y-intercept, right? Yeah. So let's see. So first of all, we're talking about whether it's a U-shape or a N-shape. We look at the coefficient of x squared, and we're determining if it's a plus or a minus. They're both plus, right? That means they're both going to be U-shape. Okay, so from here, what do? In order to get to sketching, I need to get the axis intercepts. So I'm gonna have to factorize it. But just so you know, as we talked about it before, the constant is automatically, the y-intercept is much easier to get because why? The constant, when it's in the form of y equals ax squared plus bx plus c, the constant, that is equal to the y-intercept, y-coordinate. So y-coordinate of the y-intercept. Yeah. So basically, I know that for I, the y-intercept is actually just 0, minus 10. And same with number I, the y-intercept is going to be 0, 12. So that is like super easy. And the only way to get the x-intercept for this one is to factorize it. So we could just get to it. So x-intercept, that's going to be, x squared minus 3x minus 10 is equal to 0, 2, 5. So it's going to be x plus 2, x minus 5 is equal to 0. So our x's are, so the x-intercepts are going to be minus 2, 0, and 5, 0. So those are the two x-intercepts. And for I, so we have 2x squared plus 11x plus 12 is equal to 0. So we have, 1, 2, 3, or 2 and 6, no, 4 and 3, yes. So yeah, 4 and 3, yep. So that's gonna be x plus 4, 2x plus 3 is equal to 0. So our answer is gonna be minus 4, 0, and minus 3 over 2, 0. So since we know all of the coordinates, we can draw them onto the xy plane. So the first one is going to look like, so it crosses at minus 2 and 5 in the x-axis. And for the y-intercept, it crosses at 0.12. So that's gonna look like, so how do we know the line of symmetry right away? So, okay, so if I know that it's gonna be x equals to 1 because line of symmetry literally needs to be the same distance from each of the x-intercepts. So I know it's gonna look like that, and therefore the vertex is gonna be at this point. Yeah, exactly. So it's gonna look something like that. Oh my god, that's so ugly. Let's try again. So yeah, that's gonna look something like that. So let's try for this one. Okay, so we know that it's gonna cross at minus, okay, let's move that across. So minus 4 and minus 3 over 2 and, oh, go back. Oops, I misread it. So let's do this one more time. So it says the y-intercept is at minus 10 and the x-intercept is at minus 2 and 5. Okay, so, oops, no. Okay, so from here, we know that, yeah, we know that the line of symmetry is going to be 2, 1, 2, 3, 4. So this is kind of how we do it. So 1, 2, 3, 4, 5, 6, 7, right? So if we go in 1, 2, 3, so it's gonna be like right in the middle. So that's gonna be the line of symmetry for this one, and that's gonna be where the vertex is, right? So from here, I know that it's gonna be, okay, that is so bad. Yeah, there you go. Therefore, I know that it's gonna be looking like that. Yeah, there you go. And next one we have, let's redraw that. Okay, for this one, we know that it's crossing at minus 4 and minus 3 over 2. And y-intercept is, okay, way above. That's like minus 12. 12. And so we know that the vertex is going to be somewhere in between, right? So it's going to look like that, and then it's going to cross at 12. Yeah. So yeah, so that brings us to the end of our homework solution video. Thank you for watching, and if you have any more questions, please let me know.